Hello everyone and welcome back to my lecture about microservices. In this chapter we are going to talk about the security, how we can secure the communication between different components in microservices architecture. So we start with the first point is the sensitive data. Your platform or your architecture maybe is handling two kind of data, the non-sensitive data like catalog information, for example, the data about your product, the details of product, the price of your product. The data is accessible to the public internet, so we don't need to care about the sensitive of data, not sensitive data. But in the meantime, you have some sensitive data, for example, managed by your ordering services. It can be personal information, credit card, email address, phone number, or your postal address or something like that. So this sensitive data should be encrypted, and this encryption will happen at two levels. The first level is in transit. When data is moving from system 1 to system 2, we should ensure the data is encrypted correctly. And we can use some standard algorithm like a TLS involving some SSL certificate. Once the data uh, when the data get to the system too, we need to store this data, but we need also encryption address. It means your file system will be encrypted, your database will be encrypted. And this encryption can be done using some key management, private public key. And also you should to be aware of is when we encrypt the data and when we have some backup of our system, we need to encrypt our backup should be also be encrypted. If third party has access to your backup, they cannot get the data from the backup. And usually this encryption is done by handling some private public keys, and this private public key should be stored securely in some key vault stores. We can have a lot of key vault stores, come key vault, like key vaults or like Azure key vault, EWS, KMS, as all the available key store provided by cloud providers. So another point about the security is the authentication. We need to know who is calling our service. Something is standard in the industry, and also authentication before start using your system or the private part of your system. This authentication can be done using username, password, the basic authentication to clean us to enter login and to password and the password to authenticate validate the login and the password, and after that, you can give you access to the private area of your system. And when we are managing password, that we should also encrypt password in our site. So the password is also personal information, and it should be encrypted in transit and at rest. Another option to have some kind of API key to authenticate the caller. And another way to authenticate the caller or also to authenticate the server is to have kind of two-way SSL or MTLS, mutual TLS. The server will be authenticated to the client using its certificate, and this client will be authenticated to the server using a certificate. So it's complex management, the tool, but it's usually used when we have a system-to-system communication. So, in the most common way in authentication is when we use identity server or authentication authority. This authentication authority is a third-party system. It will be responsible to store your credential, your user login, and your password, for example. And your client's application will start by exchanging the credential against an access token or a JOT token. We sure that the authentication server will check your username, your password, or your private certificate or this public passive certificate, and then we will respond back to the request or to the caller by with the access token. We will use this access token to call our backend to a microservice, and microservice will verify the access token using the public certificate or to make a request call to the authority server. So in this configuration, your microservices is not responsible to store or to manage your identity. They will just check your identity with the authentication server or the authentication authority. Both the client part and the server part trust the authentication authority. So authorization is the second step into authentication. With authentication is who's calling. Okay, you are authenticated. Your login and password is correct. So you are a user at google.com, for example. But authorization uh, is the second step here. What can you do with your authentication? Okay, you are the my client, for example, you are the profile one, but the question that we have to answer if a profile one has access to the business capability, for example. Let's have an example of shipping. Okay, to connect to your system, do you have enough authorization to handle to cancel a shipping, for example. And this kind of information will also be managed, can also be managed by your authentication provider or authentication authority. We can have kind of scope. When you authenticate to your third party, we request the scopes. Okay, my name is user one, for example. This is my password, and I want to delete a shipment, for example. And your authentication provider will give back the JOT token with the correct scope. We will get the scope, and after that we make a request to your microservice, and your microservice this time have to check if the scope is within your JOT token, for example. So another point to take care of is when you have synchronous communication between microservices. You have a kind of example. The client is calling the ordering microservices, so we will get the JOT token and the order microservice. We authenticate, for example, in this kind using this JOT token. That is a profile one, and he was going to do some stuff, and after that he has to make a request to the payment service. In this time where when the ordering service is going to request the payment services, you don't have to use system auto system credential or admin credential. We must reuse the same credential sent by the client application. We are making a request to the payment service on behalf of the client profile. So to be sure if the client profile has the authorization, for example, to handle the payment operation. So we talked about the encryption, we talked about the authentication. Another lever in the security is the network security. Usually we have communication between different tier on the application. We have clients, front-end applications, can be ASPI application or client-side application, and we have microservice. All my microservices belong in the virtual network, for example, and we need to implement some network security in the virtual network to protect my microservices. So to do that, we talked in the previous chapter about the API gateway, and I said that the the main responsibility of the API gateway is to route the request from front end to the adequate microservice. This is one of the responsibility, but we can implement in this API gateway some security responsibility. For example, we can implement some IP whitelisting to ensure all the requests we get will, will come from specific IP address, specific area in the world, specific country, specific city. We can also implement in the API gateway some firewall to protect our system against DDoS attack, to protect our system about any SQL injection and this kind of OWASP, top 10 OWASP attack. Those stuff can be implemented into API gateway, and our microservice will trust my API gateway. Once we get the request to the API gateway, we are sure the request comes from the whitelist IP, for example. We already checked the SQL injection. It's not a DDoS attacks and all the stuff. So my microservice is going to trust my API gateway and also can trust each other. And we can have some configuration even if the communication between different microservices can go through the API gateway if you want to have this kind of configuration. So we are implementing defense in depth. We are protecting our virtual network against any attacks from outside our our network. So defensive depth mean that we will have the encryption in transit. So everything will be encrypted when it's going to be stored in our system. We will implement access token or the authentication, and we need to implement also the network security to protect our security, create to protect our private zone, for example, from DMZ zone, from the external zone. So don't rely on single technique, apply multiple layer of protection to ensure that our system is correctly protected. So additional defense measure that we can have in our architecture is penetration test. So we can get help from experts. We can have some penetration test planned in the system. This penetration test can be made manually or automated. Automated security test. We can add it in our delivery pipeline to be sure before deploying any microservices. We run our penetration test against our new deployment. We can have some framework to attack detection to react quickly to this detection. For example, some passive detection. We will scan all the traffic that goes through the API gateway, and when we detect the problem, we can react against the problem. We can have some auditing of the code to be sure all our dependency don't have any vulnerability. We can have some review in our code to know who did what and when. So I'm having, for example, some code in my microservice. I know this code is secured and is doing only the job that we need to do. Thank you very much. So see you later in the last chapter.